Welcome, newbie bio students.
This is your crash course on everything water so that you can answer all of Mr. Schrader's tough questions.
And Lord knows he has lots of those.
So let's pay attention and watch. As the water temperature increases, the water begins to change from a liquid state to a gaseous state because our hydrogen bonds are breaking down. Oxygen and hydrogen gases are being released.
As ice melts in the glass of water, the liquid temperature decreases while the environment temperature remains the same. This creates condensation on the outside of the glass due to the temperature difference.
We didn't do that. Water forms. Water can be found in 3 different forms: a solid, liquid, and gas. A solid, for example, is an ice cube, which is the least dense form of water. Liquid would be the water that you drink, which is the heaviest density. Lastly, there is gas, which is a vapor that is emitted when boiling water and is the lightest density.
Water is a simple molecule made up of 1 oxygen atom and 2 hydrogen atoms, but it is essential to life. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and 2 hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atoms in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now,
High specific heat. The specific heat of a substance is defined as the amount of water that must be absorbed or lost by 1 gram of the substance to change its temperature by 1 degree Celsius. We already know water's specific heat because we have defined a calorie as the amount of heat that causes 1 gram of water to change its temperature by 1 degree Celsius. Therefore, the specific heat of water is 1 calorie per gram per degree Celsius. Abbreviate 1 cal/G/big C for Celsius. Compared with the most other substances, water has usually high specific heat. For example, ethanol alcohol, the type of alcohol in alcoholic beverages, has a specific heat of 0.6 calories per gram per Celsius. That is only 0.6 calories that is required to raise the temperature of 1 gram of ethanol alcohol for 1 degree Celsius. Hydrophilic. Hydrophilic substances are able to combine with water. Phobic. Hydrophobic substances don't mix with water, and that's why oil floats on top.
What is evaporative cooling? The science behind cool fog is based on the same natural cooling found near waterfalls, lakes, and other bodies of water. Whenever dry air passes over water, the air absorbs some of the water and evaporative cooling occurs. In evaporative cooling, tiny water particles are converted to gas and energy is exchanged, lowering air temperatures. Cool fog outdoor cooling systems are engineered to produce perfectly sized water particles to duplicate that same natural, clean cooling. By designing to the specific environment, our cooling experts can create thermally isolated areas to provide significant cooling. This outdoor air conditioning can drop temperatures as much as 30 degrees, transforming hot, uncomfortable areas into pleasant, livable spaces.
Thanks for watching this crash course on water.
Now you can answer most of the challenging questions Trader asks you.
Good luck, AP Bio newbies. This message is brought to you by New Berlin Learning Center. Expect excellence.
H2O.
Water! I'm not saying H2O. It sounded dumb if I said H2O, wouldn't it?